5.2 CRD, Quadratic Formula. So you're going to learn something very big and important today, which is kind of exciting, the quadratic formula. It's the third method for solving a quadratic equation. Some students say it's their favorite method. I'd say it's pretty easy, but it also requires a lot of calculation, and so you can make some errors. So I don't know if it's my favorite. My favorite is probably number 1, but a lot of people like number 2 too, so I'll let you decide. So 3 methods of solving a quadratic equation. Let's just quick review. The factoring method. Okay, that's where you take a quadratic and you factor it into 2 binomials, like so. You set each binomial equal to 0, and you solve, and you come up with x equals -3 and -5 in this case. The second method, completing the square, you factor something and you kind of force it to be a perfect square binomial, and sometimes it equals something. It doesn't have to equal 0. You square root both sides and you get x plus 7 equals plus or minus 3, and you solve that way. This way I also get 2 solutions typically. In this case I get -4 and -10. So that is complete the square. Now, our third method, quadratic formula, is a very important method too because it will help simplify things. Now, listen to the leprechaun when he tells you this. When you get to the book, please start at question number 14. 1 through 14 is kind of a confusing approach to explaining why this works. And I think that that section should be done with a teacher, and it will be, because on your schedule it says to have a special session with Cindy after you do this lesson. So you're going to watch the video, take your note to self, and then start the book on number 14. Okay, so let's remember, if I were going to approach any of these quadratics, I would approach them by using different methods. In this case, this is a super easy polynomial to factor. 8 has 2 factors, 4 and 2, and those 2 factors add to make 6. So this is what it factors into, and then I can jump straight to my answer, -4 and -2. If I had used the quadratic formula on this, it would have taken a lot longer. If I had used complete the square, it would work, and it would actually probably be a good idea, but it's not quite as quick as factoring. This next one doesn't factor, so I actually have to use complete the square quadratic formula. I would use complete the square because I know that if I complete the square, it needs to say +9. So I'm going to add 3 to both sides. So now I've added 3 to both sides of the equation. I have a perfect square trinomial, so I factor it. I root both sides. I'll come over here now. I'll get x plus 3 equals plus or minus √3, and I'll subtract 3 on both sides. And I'll get x equals -3 plus or minus √3 as my 2 solutions. Okay, now the next one, it looks intimidating to factor because you have a 7, you have a 13, it might factor, I might have to do big multiplication. So it might factor, but with the leading coefficient, it makes it a little bit more difficult. So then I say, okay, maybe I'll complete the square. But in order to complete the square, I need to get rid of the 7, so I'm going to need to divide everything by 7, so I'm going to have a lot of fractions. So I'd like to use another method. This is the perfect scenario for the quadratic formula. So that's why I put it on here. And on the next slide, I'm going to show you how to use the quadratic formula to solve this equation. So here's that same equation right here. At the top, I wrote standard form of a quadratic, and I wrote the quadratic formula. So there is a standard form of a quadratic. It basically means that you put it in descending order, the x squared term first, the x term second, and the constant third. It has to equal 0. It can have a subtraction sign. That's okay. So once you have it in standard form, then it's really easy to say, oh, a is whatever the coefficient of x squared is. So in this case, a is 7. B is going to be the coefficient of x, which is 14. And c is going to be the constant, which in this case is -13. Okay? Then the quadratic formula is basically just plugging in all of the equations into the formula and then basically chugging through the problem. They kind of say plug and chug in math, which is a silly term, but it's one that we use. So you're going to plug in and substitute in each of the values, and then you're going to solve for x, which will be the way to use the quadratic formula. So this is what it is, and I'm going to first read it to you. X equals negative b plus or minus square root b squared minus 4ac all over 2a. Well, great. You can go ahead and memorize that. But I have a better way. If you sing this formula to the Pop Goes the Weasel song, you will never forget it, I think, I hope. So listen, Pop Goes the Weasel is the tune. Watch my cursor too. X equals negative b plus or minus square root b squared minus 4ac all over 2a. X equals negative b plus or minus square root b squared minus 4ac all over 2a. So forgive my singing because I know it's not the best, but if you could sing it in your voice, I'm sure it would be much better. So once you have it memorized, you've got it in standard form, you know what A is, you know what B is, you know what C is. Now we're going to go through the problem. Okay, I'm trying to figure out what X is, so it stays X equals. And now I do negative B. I'm not going to write negative B, I'm going to write negative 14. Plus or minus the square root of B squared minus 4 times A times C. That square root goes all the way across. And the whole thing is over 2 times A. Okay, now we get to chug through the problem. So I'm going to recopy negative 14 plus or minus. Now 14 squared. You should maybe have that memorized. But in case you don't, use your calculator and you get 196. Now the problem area for most people is right here, because a lot of people get sign errors in here, and this is where people make errors. So I basically have negative 4 times 7 times negative 13. So I have two negatives, so that's going to make a plus. So then I have to use my calculator to figure out 7 times 4 times 13, or you can do it by hand, that's fine. 364, and the whole thing is over 14. Okay, now I go along the next step. Negative 14 plus or minus, and I do 196 plus 364, and I come out with 560 all over 14. And then I have to look at 560, and I have to see what perfect square goes into 560. So if I check around, I'm going to make this faster for you because I already know the answer. This will split into root 16, root 35, because 560 is divisible by 16 over 14. And I keep going, and I get 4 root 35. I don't like my thing gets crazy sometimes. Let's try that again. Negative 14 plus or minus 4 root 35 over 14. So I'm almost done. My radical's reduced, but I can reduce more because negative 14 and 14 all have a common factor. And the common factor is 2. So the final answer would be negative 7 plus or minus 2 root 35 over 7. That is my final answer. And I have two solutions. Notice the positive route and the negative route. Okay, so not hard, but long. I'm going to erase this so we can do the other one. Okay, so start first by assigning A, B, and C. We know A is 2, B is negative 2, and C is 5. It's already in standard form, so it's pretty easy for that regard. Now, oops, I can't have craziness with this. X equals negative B. Let's see. X equals negative B, which is plus 2 in this case, plus or minus square root b squared minus 4ac all over 2a. Now notice how I did the b squared. I did the b squared right away because that's easier. I'm trying to cut a few corners, not too many corners, but a few corners, and to make this work better. Okay, here we go. Try and get this going better. 2 plus or minus square root of 4. Now I only have one negative in here. Minus 4 times 2 is 8. 8 times 5 is 40. All over 2a, which is 4. I keep going. 2 plus or minus root negative 36 over 4. And I have a problem. I hope you see the problem too. But the problem is that I have a negative under the radical. And you can't have a negative under the radical because a negative under the radical produces an imaginary solution. So the minute I have a negative under there, I know there are no solutions to this quadratic equation. So sometimes you're going to get two solutions like I did in my first example down here. Sometimes you're going to get no solutions because you got a negative under the radical. Occasionally you get one solution, which we'll see in a few minutes. Reducing your solution. Linus has you practice this. First you have to check the radical. I think we've talked about this already, but I'm going to do it anyway. And excuse me, 80 turns into root 16, root 5 over 2. So I have negative 8 plus or minus 4 root 5 over 2. Whoa, my pen is really funky. And then you're going to reduce the numbers that have common factors. The 2, the 4, and the 8, which basically a factor of 2 comes out of all of them. So I get negative 4 plus or minus 2 root 5 over 1, and then I don't need the over 1. So that's my final answer. Okay, moving along. Sometimes you get two solutions. So sometimes you're going to get something that's x equals negative 4 plus or minus root 3. That's two solutions, and they're both irrational. Okay? Sometimes you're going to get two solutions that are rational, like 5 and 7. But you can get two solutions. Well, what that means is you're going to have a parabola that crosses the x-axis at 2 points. Okay? 1 point, 2 points. Okay? If they are rational, they're going to cross right at a perfect point, a perfect integer. If they're irrational, they're basically going to cross somewhere in the middle because they're going to be a decimal. If the leading coefficient is negative, well, then it's going to open downward like this, but it's still going to have two solutions. Okay, next. Sometimes you're only going to have one solution, and what that looks like is x equals 2. Okay? Well, if x equals 2 and you only have one solution, then it's going to cross the x-axis one place. So basically, that one solution happens to be your vertex. If it's a positive leading coefficient, then it opens upward. If it's a negative coefficient, then it opens downward. Let's say this one was x equals negative 2. The leading coefficient was negative. I'm having some problems with this, I'm sorry. It's going to open downward, and its vertex will also lie and only be on the x-axis in one place. Okay, finally, the last solution is going to be, the last type of solution is going to be if you have no solutions, like what that just happened. So that means you get x has no solutions because you got a negative under the radical. So that means that it never crosses the x-axis. Solutions is the same thing as x-intercepts. So it could look like this, it doesn't cross the x-axis. Or it could look like this, it doesn't cross the x-axis. Either one would be a no solution type of equation. So what that means is I can tell how many solutions something has based on what's inside of here. So b squared minus 4ac, that little chunk of the quadratic formula, is what they call a discriminant. So if I take a look at my expression, my equation here, I see this is a quadratic equation. I know it's a parabola. Its leading coefficient is positive, so I'm telling myself this is going to open upward. Okay, not be messy like that. It's going to open upward like this. Okay, this one has a leading coefficient that's positive. It too is a quadratic, so I know it's a parabola, so I know it's going to look like this. Well, let's see how many solutions they have. If I do the discriminant, I can tell that. This is in standard form. B is 2, A is 15, C is -1. I went out of order, sorry about that. So B squared is going to be 4 minus 4 times A times C. So my discriminant ends up being 4 plus 60, or 64. So because I know this is 64, 64 is a perfect square, so I know that this is going to cross in two places. I don't know where unless I solve it and use the whole quadratic formula to solve it, but I do know it's going to have two solutions. This one, negative b, no, not negative b, I got mixed up, sorry about that. B squared is going to be 16 minus 4ac, so that's 16 minus 4 times 2 times 4, so that's 16 minus 32. I'm going to get a negative number, which means that there are no solutions. So if it opens upward and it has no solutions, it's got to look something like this. Okay? If my discriminant equals 0, that means I will have one solution and it will lie on the axis. Okay, as I discussed in the last one. So that's it for the quadratic formula. Make sure you memorize it and use it, and remember to listen to the leprechaun and start on number 14. Good luck.